Alan Guth and Alexei Starobinsky proposed in 1980 that a negative pressure field, similar in concept to dark energy, could drive cosmic inflation in the very early universe. Inflation postulates that some repulsive force, qualitatively similar to dark energy, resulted in an enormous and exponential expansion of the universe slightly after the Big Bang. Such expansion is an essential feature of most current models of the Big Bang. However, inflation must have occurred at a much higher, negative, energy density than the dark energy we observe today, and inflation is thought to have completely ended when the universe was just a fraction of a second old. It is unclear what relation, if any, exists between dark energy and inflation. Even after inflationary models became accepted, the cosmological constant was thought to be irrelevant to the current universe. Nearly all inflation models predict that the total matter plus energy density of the universe should be very close to the critical density. During the 1980s, most cosmological research focused on models with critical density in matter only. Usually 95% cold dark matter, CDM, and 5% ordinary matter, baryons. These models were found to be successful at forming realistic galaxies and clusters. But some problems appeared in the late 1980s. In particular, the model required a value for the Hubble constant lower than preferred by observations, and the model under predicted observations of large-scale galaxy clustering. These difficulties became stronger after the discovery of anisotropy in the cosmic microwave background by the COBE spacecraft in 1992, and several modified CDM models came under active study through the mid-1990s. These included the lambda-CDM model and a mixed cold-hot dark matter model. The first direct evidence for dark energy came from supernova observations in 1998 of accelerated expansion in Rees et al. And in Perlmutter et al. And the lambda-CDM model then became the leading model. Soon after, dark energy was supported by independent observations. In 2000, the Boomerang and Maxima cosmic microwave background experiments observed the first acoustic peak in the cosmic microwave background, showing that the total matter plus energy density is close to 100% of critical density. Then in 2001, the 2 decifarads galaxy redshift survey gave strong evidence that the matter density is around 30% of critical. The large difference between these two supports a smooth component of dark energy making up the difference. Much more precise measurements from WMAP in 2003 to 2010 have continued to support the standard model and give more accurate measurements of the key parameters. The term dark energy, echoing Fritz Zwicky's dark matter from the 1930s, was coined by Michael Turner in 1998.